it just happened one night. My wife remembers it. I just suddenly said, Sarah, I know how to get rid of massive amounts of caulerpa. And I rang my friend Derek from Northland Regional Council. I remember ringing him in the morning saying, Derek, I know how to do it. And yeah, it went from there really. The idea was taking something that we already know works very, very well globally, and that's chlorine under benthic mats. And that is a contact killer. So the idea was to take that process and make a containment habitat for the chlorine and move it along the seabed. And it uses a lot less chlorine than normal benthic matting because we pump chlorine into a totally sealed off habitat and we suck it back out to the pump system and we measure the chlorine strength inside the habitat, and then we reintroduce only what's needed to top the habitat up for chlorine. As a dive company, we've always had dive teams that try and think of different ways to do things. We've got a whole team working on it. We've got some really clever scientists and clever divers. We force the habitat to be negative pressure, and that makes the habitat suck down onto the seabed, and that produces a really efficient seal. And that is then moved across the seabed. You can see exactly where the treatment's been and where it isn't, and it just moves across the seabed as it goes. Chlorides already exist in the marine environment, and a lot of people don't realise you can make chlorine from seawater. We test within seconds after we've gone over, there's absolutely no chlorine trace, which then means the seed bank that reseeds this is the seawater itself, and that's respawning the treated area after we've gone over it. It's a world's first to be able to sterilise an invasive seabed species on this scale, and it's very cost effective, so it can be multiplied. And I can't emphasise that enough. Compared to other methods we've looked at and brainstormed about, it's very quick to reproduce because it's inflatable with water and easy to scale up.